We have 3 questions for warm-up today. Solve for theta in all 3. Oh, I pocket dialed it. Okay, so let's see how you did. First of all, question number 1, that's a grade 10 trig question. That's just using SOHCAHTOA. It's your regular right angle triangle. We're allowed to use SOHCAHTOA, the definitions of sine, cosine, tan, because it's a right angled triangle. Now, given that we know the adjacent side and hypotenuse, we would set up the ratio for cos. Then we would go to our calculator and go cos inverse of 3 divided by 7. So theta would equal cos inverse of 3 divided by 7, and theta is equal to 64.6 degrees. And this is what trigonometry in grade 10 looked like every single time you wanted to solve for an angle. Okay? Now, question number 2, we're solving for theta. We've got an equation. We have to do some preliminary work to get sine of theta by itself. So I'll move the 3 over, making negative 3, then divide by 7, and I get sine theta equals negative 3/7. And so what grade 11 is similar to grade 10 is this step right here is very similar to the second step we did in question number 1. Okay? But in question number 1, we just had to do cos inverse and find the angle. Now in grade 11, since no triangle is drawn, you have to figure out where that triangle might be. And because it's looking between 0 and 360, it could be in any of the 4 quadrants. So first of all, we used cast rule to determine which quadrants it could be in. And since sine is negative, that tells us it's not in the A, because that's where all of them are positive, and it's not in the S, because that's where sine is positive. So our 2 triangles have to be in quadrant 3 and quadrant 4. Label your reference angle. So here would be theta r, and here would be theta r, and draw a triangle back to the nearest x-axis. And we would know on this triangle that the opposite side is 3 and the hypotenuse is 7. And so what this allows you to do is it allows you to draw a triangle like you had in grade 10. And once you have a triangle drawn like you had in grade 10, you can solve for the angle. And again, we'll make this note that when you're solving for a reference angle, you're solving like a grade 10 triangle question. The 3/7 has to be positive because it's an actual triangle. So then you can go to your calculator and do sine inverse of 3/7. And we get 25.4 degrees as your reference angle. So that means your actual angle in quadrant 3, here I'll do it, I'll label it in green. This would be my actual angle. In quadrant 3, I would have to do 180 degrees is up to here. 180 degrees plus 25.4 to give me 205.4 degrees. And in quadrant 4, to get this as my angle theta, I would have to go all the way around 360 minus 25.4, and I get 334.6. So grade 11, the triangle isn't always given, you're just given the equation, and you're given a range from 0 to 360 to solve this question. That means it could be in any of the 4 quadrants. We need to use our cast rule and our reference angle to figure out what the actual angles are in standard position. And then also in grade 11, question number 3, we have a solve for theta, but we notice that this is not a right-angled triangle. So far, the only thing that we can solve for in non-right-angled triangles is the sine law. So for the sine law to work, you need to recognize if you have an angle and its opposite side, which we do there, those ones we can use. And then you could find either an angle or an opposite side if you had another piece of information. So the other piece of information that we have is this 5. That 5 would go with this angle x. Notice, right now, I cannot solve directly for the angle theta, because opposite of the angle theta, I didn't know that side. But I could solve for x. So we set up our trig ratio, or our sine law. Our sine law says you can put either the angles on top, or you can put the sides on top. In this case, we want to solve for the angle, so we'll put sine of x, it goes with 5, equals sine of 40, it goes with 8. It's not hard to get sine of x by itself. I can type this into my calculator, and I get sine x equals 0.401. At this point, you are at, draw a purple arrow here, we are at the same place we were with the purple arrows in the previous questions. You got sine or cos by itself. Okay? It is similar to question number 2 because you could have a possibility of 2 answers. Okay? It's similar to question number 1 because a triangle is drawn, but because the triangle is not a right-angled triangle, you're not guaranteed that you can just go sine inverse and be done. Okay? So what we have to take into consideration is we have to take into consideration the cast rule. We have to say that sine is positive, so that's here and here. Those quadrants are where sine is negative. And there could be an angle in quadrant 1. There could be an angle in quadrant 2. For both of those, this would be my reference angle for x. Draw a triangle to the nearest x-axis. This would be the actual angle, x. So I want to find my reference angle. If I want to find my reference angle, I go sine inverse of 0.40174, 23.7 degrees. So that means that x, well, in quadrant 1 it will be identical to 23.7 degrees, but in quadrant 2 it would be minus, you'd have to go all the way here to 180 and then minus your reference angle, which would be 156.3 degrees. I'm just going to scroll up a little bit back to our triangle, I'm going to put those two numbers side by side here and just think about them. One possibility, we'll do it in green, was 23.6. The other possibility was 156.3. 23.7, sorry. 23.7 and 156.3. Do any of them not make sense? Yes. Can you see that 156 is way too big? Because if I have the 156, then I'm already over 180 degrees. So in this situation, the 156 doesn't make sense. Do you remember when we were looking at it yesterday, we said if the angle, right, if we go back to, right, if we go back and think of this, remember when the side opposite the angle is bigger than the adjacent side, we only could draw one triangle. Can you see that that was the situation in question number 3? You see the opposite of the 48 was bigger than the adjacent side of 5. So some people use that already and just say, I'm just going to find one angle because I know only one is going to work. I showed you that you still can find both angles and check them and find out that way that only one angle works as well. So as a result, we now know this is 23.7, and the last thing, we still haven't found what we were looking for. We were looking for theta. Theta is going to now be 180 degrees minus the 40 degrees minus the 23.7 degrees. Will give us 116.3 degrees. So what I wanted to do with this as a startup is I wanted you to see how the trigonometry you learned in grade 10, which was just SOHCAHTOA, connects to the starting point of trigonometry in grade 11, where you go past 90 degrees, and how that works, and then connects to what we were doing last class with the sine law and dealing with triangles that aren't right-angled triangles.